Okay, so we've identified some strong positive and negative correlations. What we can do next is explore these in a bit more detail using the scatter plots and even line plots. So the early examples from example 2 and 3, and then selecting the groups of correlated variables. So for example, I'm just picking all of them here. So that's H, M, and O, remember, were strongly positive correlations. A, J, and S had some negative correlations. So if I pick all of those, I can use my subplotting code to draw scatter plots of all of them. Okay, and you can see I've got, so there's 6 of them, so 6 times 5 is 30 divided by 2. I'm going to get 15 subplots, so I can fit them into a 4x4 square. But apart from that, the rest of this code is unchanged. It's just I've changed the selected values and I've changed the subplot size, so 4x4. And there you can identify some of the strong positives. So you can see that H and M, H versus M, H versus O are strongly positively correlated. Those are the 0.9 numbers that we saw in the heat map. Okay, that still might not be close enough detail. So you could just focus on the strong positive correlations. So there I've got H, M, and O. Again, there's 3 variables. So 3 times 2 divided by 2 is 3 plots, and so I can fit them in a 2x2 square, and there you can see this, the correlations really strongly. Or we could look at the negative correlations, A, J, and S, and we'll see J and S are strongly correlated. A and S are not quite so strongly, and A and J are positively correlated, but not very strongly. So that gives us a picture of the correlations that we've found in the heat map. What we could do then is actually go back to the time series, try and get a sense of why these correlations are occurring, and we can find a bit more information out by doing that. So the first one we're going to look at is those strongly correlated variables, H, M, and O, and we'll plot the time series, but we'll use a rolling average to get a sense of what's the general underlying direction of that line. So that's what happens if you do it, and immediately you can see that H is the blue one, M and O are the sort of orange and green ones. And you can see that M and O are really closely aligned, especially their rolling averages. There's a bit of noise in that figure, but their rolling averages are really closely aligned. But H doesn't look like it's correlated, except if you notice that it's climbing at pretty much twice the rate of M and O. So the distance between them is increasing steadily, and that can lead, as we've seen, to a strong correlation. So a possible explanation, we can't really explain, we can't really deduce this from the information we can see, but a possible explanation would be that every time somebody buys 2 H's, they also buy an M and an O, whatever those things are. That would explain those correlations. If we look at the negative ones, we can see. So that, remember, there was some negative. I think we saw that. What was it? A and J are declining slowly, while S is climbing slowly. So A and J, I think if we remember, A and J were correlated positively, but S is negatively correlated against each of them. So S and J are negatively correlated. I think that's right. But they don't look very similar, and in fact, the correlation here is arising from something different to the previous picture. It's because they've got similar peaks and troughs. So if you notice, around about where is that? Towards the beginning of March, towards the end of where's that? Sort of beginning of June, beginning of September, those kind of times. There's a peak in the green one, which is S, and there's a corresponding trough in the other 2. And there could be a lot of reasons for that. One could be that the sales are somehow seasonal. Maybe if you think about fashion, for example, there's regular releases of catalogs, and that can drive sales up. It might drive other sales down, or maybe everyone buys. Every time someone buys a J, they're buying several A's. That's another possibility that's going on there. Or people are gradually switching to S from J. So S is growing and J is declining, but there's some sort of seasonal thing going on. We'll look at seasonal distributions next week. Okay, but we can see there's some interesting information going on there. We may not have enough information to explain it, but we can see that there's definitely something going on. Right, so at this point I'm going to we've done about as much as we can looking at that data. I'm going to stop the video here, and then we'll have another video and we'll look at add some extra data into the investigation.